150-degree angle would be up to this way, counterclockwise, up to 90, and then over to 150. All right, and then we would have something like that. 300-degree angle would be all the way around to 300, and that would be your angle. Negative 210-degree angle, we would be going in the opposite direction, and we would come up to here, and that would be our angle. All right. Next, it says convert the following from radians to degrees and degrees to radians. So, if we're starting in radians, we're going to multiply by 180 over pi. And that's going to give us 225 degrees. And the pi's cross off, multiply, and then simplify, right? Multiply by 180 over pi here. The pi's cross off, and we get negative 240 degrees. Here we're given degrees, so we need to multiply by pi over 180, and we get 3 pi over 4. And here we multiply by pi over 180 again because we're given degrees. And we end up getting negative 11 pi over 6. Don't forget these negative signs, they're huge. They make a completely different angle than positive. All right? So scrolling down, evaluate the arc length and sector area of the given the following information. All right? Well, we know that our arc length equals r theta, and our sector area equals 1/2 r squared theta, where theta is always in radians, right? So we're given degrees here, so we need to immediately convert that to radians. So we'll multiply it by pi over 180, and that gives us 7 pi over 6. So if we're trying to find the arc length, that would be equal to r theta, which is 3, times my theta, which is 7 pi over 6. And we get 21 pi over 6, which actually equals 7 pi over 3. And then when we're trying to find our sector area, it's 1/2 times my r squared, so 3 squared, times my theta in terms of radians, and we know that that is 7 pi over 6. And when we multiply this out, we get 63 pi over 12, which is equal to 21 pi over 4. All right. Now when we look at here, we already have our degree, our theta in radians. So we know that S equals r theta. So our arc length equals 4 times a negative pi over 3. And this equals negative 4 pi over 3. But as we know, arc length can't be negative. It's just a distance. So this actually equals 4 pi over 3. All right? And the sector area equals 1/2 r squared, so 4 squared, times my theta, which is negative pi over 3. And this equals negative 16 pi over 6. And since we can't have a negative sector area, this reduces down to 8 pi over 3. And that's our final answer for that one. All right, moving on to number 10. Find the arc length and sector area of the given circle below. We're looking for this arc length and this entire sector area. All right? So basically, based on the formulas that we were given, S equals, well, we know our arc length equals r theta. Our r is 5, and our theta, let's convert that up here, 62 degrees times pi over 180. And that's going to equal 31 pi over 90. 31 pi over 90. All right. So then we come back down here. We know our theta is 31 pi over 90. And that's 5 times that is going to be equal to, after reducing down, it's going to be equal to 31 pi over 18. So our S is 31 pi over 18. And our sector area is going to be equal to 1/2 times my r, which is 5. Oops, let me go up here and grab this. My r, which is 5 squared, times my theta, which is 31 pi over 90. And all this is going to come out to 775 pi over 180. And that reduces down to 155 pi over 36. So 155 pi over 36. All right.